Section 2.4. We're still sticking with talking about lines. 2.3 was talking about y equals mx plus b. And now we're getting a new form in 2.4. And on the yellow sheet it says, I can use all three forms of lines and determine which form is best for a given problem. So right now you're probably saying, yeah, I know y equals mx plus b. There's two more? Yeah, there's two more. You know, that's what we're going to get in 2.5. So if you could rate yourself before the lesson, usually most people remember y equals mx plus b. But we have two more forms that we have to talk about. And then you can tuck those away. And I was just looking, I think we'll probably be able to do all the stuff we need to do with the second form today. And then tomorrow's notes will be about the third form. So after that, you'll be able to rate yourself after the lesson. So in 2.4, oh, everybody found it in their note packet? What page is it? 16? Thank you. So page 16, we're still talking about lines. So more about linear equations. Here's our big deal. We want to write an equation of a line given its slope and a point on the line. Now, notice it doesn't say given its slope and given its intercept. In 2.3, that's what we studied. But that's not really reality. You know, in real life, they don't always hand you, here's the slope and here's the y-intercept. Most of the time in real life, we get a couple of points, and we have to figure out all the good stuff. And so that's what we're starting today, is the more realistic way that this will happen. We're going to write an equation of a line given its slope and a point on the line. And that brings us to this fabulous new formula called point-slope form. And it is one that even the state says you have to memorize. I always think it's so funny when they hand out the formula sheet for the MCAs, y equals mx plus b is on there. Like nobody knows that one, you know. And then they leave this one off. So they expect you to memorize this one. And it's y minus y sub 1 equals m times x minus x sub 1. So we've got to memorize that. We have to know, which of course we already do, that m is slope. And then we have to figure out what this x sub 1 and y sub 1 business is. Well, just like when we use the slope formula, that means that's a point. So this is the point, x sub 1, y sub 1, that's on a line. So it's a point, and it's a slope. Now, that brings us to the interesting part of point-slope form, which is this. I have a question for you. How many points are on a line? How many? More. How many points are on a line? Let me talk you through it. A line has arrows at the ends, right? What do those arrows mean? It goes on forever. There are an infinite amount of points on a line. You know what that means? There are an infinite amount of these equations that can be written. Well, we don't want that. Back of your book is supposed to have the odd answers in there. If it's infinite, it's not going to fit. It's going to go on forever. So what we usually do is we start with this formula, but we end with slope-intercept form. And that's because there's only one slope-intercept form for a line. So problem 1 says, write an equation of a line passing through the point, negative 1, 3, with a slope of negative 2/3. And my first thought is, so which formula should I use? Well, it tells you right in the problem, silly. It says it's a point and a slope. So I need to use the point-slope formula. And this is one of those where, for years, you know, people are like, Cedarholm, you make up songs about stuff. Can you come up with one like this? I've never been able to find a tune or a song that works out really good to memorize this one. It's just kind of like you have to know it, you know. So then I think, all right, this is obviously m. This is obviously x sub 1 and y sub 1. So seriously, I just put those numbers in there, and then it's in point slope form. Yeah, seriously, we put those numbers in, and it's in point slope form. We just have to be careful. Y minus 3 equals negative 2/3, because that was m. And then x minus a negative 1, we're not going to write that. Minus a negative is plus. Now, like I said, if they ask us to write it in point slope form, technically we're done right here. But when we go to check it in the back of the book, it's going to be in slope intercept form so that everybody has the exact same answer as it goes through. So we would continue on, distribute the negative 2/3. So negative 2/3 times x is negative 2/3 x, and negative 2/3 times 1 is negative 2/3. And then I realize it's almost y equals mx plus b. All I have to do is add 3 to both sides. Oh, but this is a fraction. Well, that's okay. We just have to get a common denominator. So here's what we're trying to do. Negative 2/3 plus 3 over 1. That's what we're really trying to do. So I look at it and I think, well, then they both need a common denominator of 3. That's what I have to do. So this one is going to need a 3 on the top and the bottom. Oops, I'm getting ahead of myself here. Like so. Well, everybody can do that. That's going to be 7/3. See it at home? Fractions have never been my friend. Yes, I understand what you did over there, but I might miss it. Well, that's what this is for. This amazing machine will practically do the laundry for you. This little thing will do fractions for you. And in fact, it'll even give you the answer in fractions. So if you didn't want to do that in your head or by hand, you could punch in parentheses negative 2 divided by 3 parentheses. That stands for negative 2/3. Add 3. See at home, you lied. It's a decimal. Give me a second. Hit the math button, number 1, and enter. Look at that. You don't have to do fractions by hand. You can use your graphing calculator for that. So, that takes some of the stress off, doesn't it? Dealing with fractions. We get the same answer. There it is. Now this one says, what's an equation of the line through this point with the slope? So I start thinking, I think I know what formula I should be using here. That's a point and a slope. I better use point slope form. Now I just have to figure out what goes where. So we label. Then we kind of think simplifying as we go through. Y minus, oh, I have to do minus a negative 1. Should I put minus a negative 1? No. You could, but in the next step, you better change it to y plus 1, because again, it's Algebra 2 and we simplify everything. What should I put in for m? Big old negative 3 right there. X minus 7. Again, that's probably not the answer we're going to see in the back of the book. They usually make them slope intersect. So what would we do next? Distribute that negative 3, so be careful. It's going to be a plus 21. It's got to go to both of them. Almost done. Super close. What's left? Subtract a 1 from both sides. Now, when everybody looks in the back of the book, they'll all see the exact same answer, because slope-intercept only has one form, but point-slope has an infinite amount of forms. So Well, this doesn't seem too bad, huh? It's a formula. Once we know the formula, we should be good. And then they take stuff away. So what they do, remember, I've mentioned this before, the sign of a good mathematician is you're always thinking, how can I get this to look like the thing I just knew how to do? How do I do that? What is an equation for a line passing through 5, 1, and 7, 9? Leave the equation in point-slope form. Okay, so this must be a new formula, point-point formula. No. If we know 2 points, what's something we already know how to find from the previous sections? Slope. That's where we start. We need the slope. Slope, slope, find the slope. Average rate of change. y2 minus y1 over x2 minus x1. That's slope. So, you can label like crazy. Although you're probably not doing that anymore. You know, after the first slope assignment, you're probably like, I don't need to write all that down. 9 minus 1 over 7 minus 5. Whoops. I'm doing the denominator already instead of keeping my thoughts on where I'm at. Slope of 4. So now, not only do I have 1 point, but I have 2 points. And I have a slope. That's point-slope form. But there's 2 points. Which one should I use? Turns out it doesn't matter. In the end, they're both going to be the same line. So I could use this first one and say it's y minus 1 equals 4 times the quantity x minus 5. And somebody else out there could say, no, 7 and 9 are my favorite numbers. I'm going to use those. And those would both be correct. Now, I want to show you that they are both correct. So, technically, this is our answer. It said, leave it in point-slope form. Either one of those, beautiful answer. But I'm going to show you what both of these look like in slope-intercept form. Oh, except my 19 doesn't really look like a 19 there. It looked like an alien head. There, that's better. You see how it gave us the same line anyway? Yeah. And there are an infinite amount of points on a line. So there could be an infinite amount of point-slope forms. But this is the reason why they give us these answers in the back of the book. Because there's only one right answer then, and we're not trying to check everybody's individual. So, point-slope form. All right, I'm going to call on people. What's an equation of a line that passes through this and this? Leave it in point-slope form. So, Gavin, what would we do first? So, you go into the point-slope formula right away then? Like this? Or were you thinking something else? Okay, so this thing is called point-slope formula. What do we have so far? Go ahead, Gavin. What do we have so far? What information, what are these called? Yeah, we've got 2 points. We're short something. So, Matthew, what are we short? Yeah, we don't have the slope. So that's where we're going to start. I mean, this is a great way to think about it because you can go, okay, I got a point, but I don't have the slope yet. So some of you have already done it. Slope, slope, find the slope. Average rate of change. y2 minus y1 over x2 minus x1. 7 minus 0 is 7. 0 minus a negative 5, minus a negative is a plus. Yeah, we got kind of an ugly little fraction there for our slope this time. Are we ready to go to point slope form now? Cool. So, Maddie, thoughts? You like one point better than the other one? Because you looked at it and saw there's no negative in this one? Cool. I like that reasoning. There are other people that that say, I like the negatives, because then when you put the negative in, it becomes a plus. Either way, it's working. So y minus 7 equals 7/5 times x minus 0. Do you suppose it's okay to leave that x minus 0 in there at the Algebra 2 level? What's x minus 0? X, yeah. So that would be the point slope form. This one, it's so hard. You really want to add the 7 and get it over there in slope intercept form, but it did say leave it in point slope form, and we just simplify it and say we're done. Now, this one said, how is problem 2 different from problem 1? What did they take away? They did. Was there like section, it was 2-1, I believe. Yeah, 2-1. All about slope. We should know totally about slope by now so we can find slope. They took away the slope. And like I said, that makes it much more realistic. You know, in real life, you have data points that you're looking at, you know, and you have to calculate the slope. So it is much more realistic. Well, look at this. That's a little of the G word. Geometry. Not everybody likes to hear that word again. These are parallel lines. What do you know about parallel lines? Nothing. Slopes are equal, okay? Same distance between those points as you go through. They ever going to hit each other? Never going to happen. That's parallel. So the big deal for us, the slopes are the same. That's going to be the big deal for us. The slopes are equal. Because they're going to say, hey, here's a line. Write an equation for a line that's parallel to this line. And our first thought has to be, ooh, slopes equal. Slopes are the same. Those are the perpendiculars. You remember the little symbol for perpendicular from geometry? It's like an upside down T. Basically, it's to show two right angles. That's what it's for. But this one's harder. This one, the slopes were equal. That's a two-parter. Something reciprocals of each other. Do you remember it? Negatives, opposites. The slopes are negative reciprocals of each other. So not only do you have to put a negative in front of it, but you have to flip it. That's what a reciprocal is. Taking a fraction and flipping it. Now, notice with this first one with the parallel, where it hits the y-axis, we talked about the fancy name for that. That's the y-intercept. These are two different spots. Right there. But their slopes are the same. So they don't ever hit each other. Over here, these better be right angles or this is not perpendicular. Has to be right angles. And how that happens is the slopes are opposites and reciprocals of each other. So this one says, what is the equation of each line? Well, I don't know. I need more information. Simplify final answer to slope-intercept form. Okay. What do they want? They want a line that is parallel to this one through that point. So I think about what we just did in the last problem. And I think they took slope away from us again. Somewhere up here, there is a slope that I have to use. What is the slope? It is 5. When it's in slope-intercept form, all you have to do is look for the number that's in front of x. That's your m. So if we are going to write an equation for a line that's parallel to that one, we have to have the same slope. It's going to be 5. And then we have to use this little point because they told us so. And I realize, well, that's a point and a slope. Duh, I should use point-slope formula. Y minus y sub 1 equals m times the quantity x minus x sub 1. So now I just have to put stuff in the right spots. Jaden, what am I going to put in for y sub 1? There's x sub 1 and y sub 1. I need to know what to put in for m. Jordan, what should I put in for m? Yeah, that was that slope for the parallel there. And then I need to know what I should do about a little x sub 1 business there. Xander, what should I do for that? Excellent. Did you hear what he said? He said add 2. So he looked up here and said that's a minus 2, so we're going to add 2 right back there. Now I need to know if I'm done, because I'm thinking, hey, this is point-slope form. But remember all that blah, blah, blah? You got to read that carefully. Because this one says this time it's not okay to leave it like that. We want you to keep going. So I need to know how to keep going. Neil, thoughts? What could we do to keep going? Distribute the 5. Sounds like a good way to go. We distributed the 5. Bill, can we finish it up? How do we get it to look like y equals mx plus b? Exactly. So, I'm going to have to write over here. I wrote too big. Y equals 5x plus 11. So we started with point-slope form, but it said, make sure you put it in slope-intercept form. Okay, did that. B says, we want the line perpendicular. Ooh, that's different. Perpendicular to y equals negative 4x plus 2/3. And through the point, 8, 5. I have a point. I need a slope. There must be something up here that I'm supposed to catch that's going to help me out with that. So, Zach, what is supposed to help me out with slope? Good. Here's the problem. On the test, somebody always wants to use that one. If it's perpendicular, is it the same slope? No. It's about as different as it can possibly be, right? You have to take the negative off and you have to flip it. So, I always have people write it like this so they don't accidentally come back and use the negative 4. The slope of the perpendicular is even. Excellent. Opposite and reciprocal. And then do this. This is called a strike in math. Every year, somebody accidentally uses a negative 4. Put your strike through it. You should never scribble out your work. Just put a strike through it in math. We've got it. So now, I'm supposed to use this and this and see what I get. So, Amos, thoughts about the formula we should use? Oh, you're already putting it in. You're ahead of me, Amos. You're ahead of me. So Amos was going to put this stuff in. Like so. Now, this was part A and B to the same problem. Were we supposed to stop at point-slope form? We already had to do the slope-intercept thing, didn't we? So, like I said before, if fractions freak you out, you could always use the graphing calculator to do the math. We would distribute the 1/4 And remember, 1/4, it would be negative 8 over 1. You can either cross reduce, or you could just say top times top is negative 8, bottom times bottom is 4. Negative 8 divided by 4 is negative 2. Or grab a calculator. Don't let it freak you out. Grab a calculator. Now we're super duper close again to having this answer here. So, all done already? Okay, I'm going to look at that as a good thing. Britta, I have one more thing to do, right? What do I have to do? I got to add 5. So we want that in slope-intercept form. There it is. And again, you can kind of check it because you're looking at this 1/4 and thinking about your negative 4 up there. Yeah, my slope was supposed to be the opposite and the reciprocal. That worked out pretty good. So point slope form. Well, I'm definitely going to hit you up for more help this time. I've been leading you quite a bit today. So, just going to put some questions out there and see if you can tell me exactly what we need to do. So, what is the equation of each line? Simplify, final answer to slope-intercept form. It's exactly what we were just doing. And the line parallel to 4x plus 2y equals 7. Let's start with this. I think it's going to be a little harder to find the slope we need this time. Do you see why? Anybody see it? Yeah. Yeah, and the other ones, it was like y equals mx plus b right away, right? And it was all great. With this one, they're going to make us do a little work. So we're going to have to subtract 4x from both sides, because it has to be in slope-intercept form for us to find the slope. Then we have to divide by 2, which makes people nervous because they're like, oh, 7/2 is a fraction. Do we care that that's 7/2? What did we need out of that? Yeah, and the slope is? It's the negative 2. So it's, it's good that we're able to get that fraction in the back, but what we care about is a slope of negative 2. Now ask yourself, is that the slope I should use, or do I have to do the opposite and the reciprocal? That's the one? Yes, because they're parallel. Did they give me a point? Well, then I don't really have a choice over the formula, right? What formula do I use? Yep, point slope form. There it is. Looking pretty good. So I want to know what the left side of this thing is going to look like. Sean, what's the left side of this going to look like once I put the right number in here? Good. Y minus a negative 2 is y plus 2. Now I'm going to want the right side, so think about what you would say if I called on you. And even. Everybody agree? Is it done? No? What's next? Okay, let's distribute the negative 2. Be very careful because it's a negative. Make sure you have that plus 8 back there. Almost done? What's the last step? Subtracting 2. I have y equals negative 2x plus 6. Is that a go? Can we tell that this is parallel to this? Just by looking at the slope, right? This has a negative 2 for the slope, and this has a negative 2 for slope. So first thing they took away was slope. Second thing they took away from us was slope-intercept form. They gave us this one. This is called standard form. That's the one we're going to study tomorrow stuff. But we can do this. All we have to do is move stuff over. That's it. So this one wants the line perpendicular to the line y equals 2/3 x minus 1. And it's going to go through the point 0, 6. Okay. So, Jaden, thoughts? We have to change it. So your first thought was they gave us a slope, right? Okay, so this slope is 2/3. And we have some big changes we have to do. What are those big changes? Neil? Yeah. So this one, because of the word perpendicular, we have to do flip and negative, or negative and flip. And this is where, like I said, I encourage everybody to strike that first one so that you don't accidentally use 2/3. You know, you look over there and you go, oh, there's M, and yeah, you're on your way. So you have to be more careful with these. All right, where should we go from here? Point slope form. That's what we've been doing all day. What's the left-hand side going to look like? It sure will. Oops, that doesn't look like a minus anymore. Almost looked like division because I made a little dot. Right-hand side? Felt really weird to write that, right? Because what should it really be? Just x. Because x minus 0 is just x. Done! Super close, though. What's left? Got it. So what do you know about parallel slopes? Nothing. What do you know about parallel slopes? They're the same. How about perpendicular slopes? Opposites and reciprocals. Yeah, it's that whole two-piece thing for perpendicular. That's a little bit more involved. We'll save that one for tomorrow. That's standard form. And we'll get some practice today at our point slope form, which you were doing fabulous at. Really, really good job, everybody. Okay, and I don't remember if I've told this A day or B day or what. I don't think I have yet. Obviously, we'll have to use the squirter over here of hand sanitizer, but if you have to do any graphing, I always have graph paper in these 3 metal baskets over here. This first one has the nice little negative 10 to 10 graphs. The middle one big, huge group of blocks in there for you to make your own. And then the third one is for trigonometry graphs. So those are my pre-calculus students. But if you have to ever do graphing, I know that some students don't like graph paper because they lose it, you know. You don't have to use graph paper. You can make graphs on your regular note paper. This assignment might not have it. I'll peek. Because this was more about writing them than graphing them. I don't think you're going to need the graph paper today. Oh, I better